Hey guys, today I want to talk to you about rates. So we're going to be taking notes on lesson 1-3, rates. Now that kind of sounds like ratio. I'm trying to get into November. What's wrong with me? 10, 23, 18. So that kind of looks like ratios. So it's sort of like a ratio, kind of looks like a ratio, written like a fraction, except for we're going to have a little change up, okay? So let's go through some definitions. First off, what is a rate? So rate is a ratio. See, I told you it was there. Comparing two quantities. Okay, that sounds just like a ratio. But wait for it. Two quantities with, and here comes the big thing, different kinds of units. Okay, so what do I mean by that? Miles per gallon. That's a rate. Feet per second. That's a rate. Dollars paid per day. That's a rate. So that's all a rate is. It's comparing two different quantities, but the key is they have to have different types of units. Ratios, we're comparing two things with the same units of measurement. So that's why I didn't see it in the answer, because they canceled each other out. Okay? But rates are just okay. But where we get to really interesting thing is unit rate. So let's talk about him. So unit means one. Rate is a comparison of two quantities with different kinds of labels. So that means what we're going to do is take what we have, and we're going to make sure that the denominator number is going to be written with a 1. Okay? So a unit rate is a rate, so still two different labels, with a denominator of 1. That's what unit stands for, 1. Denominator of 1 unit, so whatever that unit of measurement is, when the rate is written as a fraction. So it's got to be written as a fraction. It's written as a fraction. Okay, so let's compare what we talked about yesterday to what we're talking about now to what we're talking about even sooner, or more recently, the unit rate. So let's talk about, first off, what is a ratio? So a ratio deals with numbers only, so there's no labels. Okay, so for example, we're going to compare 15 to 5. Oops, sorry, I say 5 and I write 3. And then we can simplify this. They both have a 5 in common, so 15 divided by 5 is 3, and 5 divided by 5 is 1. So this is one of the rare times you can go ahead and keep 1 in the denominator. It's when we're talking about a ratio. Okay, so let's look at a rate. Now what we're going to do is we're going to add units. So what does that 15 stand for? What does that 5 stand for? So we could say 15 characters (5 seconds). So you might say, what the heck does that mean? Well, typists are measured in how many characters or keys that they can strike in 5 seconds. That's what this is all about, okay? So how do we go from the ratio to the rate to the unit rate? Well, I actually kind of jumped the gun on that, and I already showed you what the unit rate is. So the key idea about a unit rate is you're going to divide top and bottom by the denominator. Okay, So if I take 5 seconds, or 15 characters, and divide by 5, and take the seconds and divide by 5, what I'm going to end up with is a unit rate of 5 characters. So here I go again. I think I must be in love with the number 5. 3 characters per second. Okay. So again, there is a relationship between the word unit and the 1 in the denominator. Okay? All right, I have just a couple more things I want to say, so I'm going to go to the next screen. And then we've got the examples that we glued into our composition notebook today that we're going to go over. So let's talk about unit price. So unit price is a unit rate, but it deals with money. That's the only big difference. So unit price is the cost, which is money of some sort. Could be dollars, could be change, per 1 unit. So if you ever go to the grocery store with your parents and you look at the shelves, you're going to see little kind of yellow slip that's underneath the product with the price, and it's going to tell you what the unit price is. So what does it cost instead of for the 48-ounce jar? What does it end up costing per ounce? Because only then can you actually compare prices, is if you look at the unit price. So that's a pretty big idea. Okay, and last thing before we go into our examples, unit rate and unit price can be solved using division. And that kind of makes sense because we've got a fraction, and a fraction bar just means to divide. Okay. So another way that we could have solved the 15 characters is if we said 15 characters. So this is what our unit or rate looks like, 5 seconds. So I can take the 2 key players, the dividend of 15 and the divisor of 5, and 5 goes into 15 exactly 3 times with no remainder. So then I can interpret that to be 3 characters per second. Now, a lot of times what you're not going to see is somebody using the 1. They'll just say per second, but it assumes that's per 1 second. Okay? So this is the kind of stuff that we're going to be talking about today. So I'm going to switch to the next screen. Give me just a second. I'll be right back. Voila, I'm back. Okay, so basically what we're going to do is we have 4 problems, and we're going to solve them. So Alma downloaded 35 songs in 5 minutes. How many songs did she download per minute? So I just really need to listen to the words, and I need to listen to their order, and that's going to tell me how to set up this problem. So she downloaded 35 songs, so that's the first thing mentioned, in 5 minutes. So minutes is the second thing mentioned. How many songs did she download per minute? So that's pretty important there. Per minute means 1 minute. Okay, so this is actually asking us to take our rate and turn it into a unit rate. All right, so how do we set it up? Well, we have 35 songs, and we're going to compare that to 5 minutes. Okay, and then what we want to do is reduce. So we're looking to how do I get the denominator to become 1? So that's the guy that's going to tell me what to do. So I'm going to end up dividing top and bottom by 5. If I divide them both by the same thing, 5 over 5 equals 1. So I'm not going to change the value of this problem. I'm just going to change its appearance. It's like going on a diet. Okay? I can go on a diet, I'll still be me. I just might be thinner. Or let's say I pork out on too many cookies, which I tend to do, or peanut M&Ms when I'm grading tests, and I get fat. Okay? It's still going to be me. There's just more of me to love, right? So divide by 5, and I get 35 divided by 5 is 7, and the label is songs. And then per, and 5 divided by 5 is going to give me 1 minute. So what I can say is, and I'm going to write it off to the side here, Alma downloaded 7 songs per, or in 1 minute. We can say per minute. We'll just say it like that. We won't even put the 1 in there. Okay? So that's the first one. Next, we've got Jonathan is baking several loaves of bread. How exciting. To sell in his bakery, he used 9 cups of water and 12 cups of whole wheat flour. How much water was used per cup of flour? Hear that per, that means divide by. So what came first? The water, right? So that's the first thing. What came second? That would be the cups of flour, of whole wheat flour. Okay? Now, the question doesn't ask for how much water was used per 12 cups of whole wheat flour. It wants to know how much water was used per cup, as in 1 cup. So let's set up our ratio, our rate, excuse me. We have 9 cups of water. And we're going to compare that to 12 cups of whole wheat flour. Okay? Now, this one's kind of strange because it says it wants it per cup. Okay? Per cup. So in other words, I would need to divide top and bottom by 12. So let's kind of see what that looks like. So I'm going to divide by 12, divide by 12. So in the numerator, I'm going to have something that looks like this. 9 cups water over 12, and then I have all of that over 1. Oops, sorry, let's go back to blue. Sorry about that. 1 cup whole wheat flour. Now, this looks too strange to have a fraction and a fraction, so this is how we deal with it. 9/12 divided by 1 is 9/12. In addition, do you guys see what I'm seeing? 9 and 12 can get simplified. They both have a 3 in common. Okay, so what does that give me? Well, I have 3/4. Okay, now what changes? On top is I have cups of water. Or I'm going to write that a different way. I don't like that. See, this is what happens when I do this too late at night. So I have 3/4 cup of water per 1 cup whole wheat flour. Okay, so how do I interpret this? I'm going to say, Jonathan used 3/4 cup of water for each cup of whole wheat flour. Okay? All right, this is kind of a weird problem down here, but I like it. Comparing a baby to a hummingbird. So a human baby's heart beats about 7,800 times in 60 minutes. A hummingbird's heart rate while resting is about 7,500 beats every 30 minutes. How many more beats does a hummingbird's heart beat in 60 minutes than a human baby's heart? Okay, so we've got a baby, and he's 7,800 beats per 60 minutes. Okay, and now we've got the hummingbird. That color. Hummingbird. And his heart is 7,500 beats per 30 minutes. So the problem is I can't really compare these two unless they have the same denominator. So what we're going to do is we're going to multiply the denominator by 2 and the numerator by 2 in order to get the denominators to match up. So what I end up with is 0, 0, 10, 14, and 1 is 15. 15,000 beats per 60 minutes. So now I can go ahead and figure out what the difference is. How many more beats does a hummingbird's heart beat in 60 minutes than a human baby's heart? So I'm going to take that 15,000 beats per 60 minutes, and I'm going to subtract them. So I'm going to subtract the 7,800. Minus 7,800 beats per 60 minutes. And so I can just do the math off to the side, lining up place value and subtracting. So this one I have to rename, and I get a 2, rename, and then 14 take away 7 is 7. So I get 7,200 over 60. So remember what 7,200 is, it's beats, and remember what 60 is, minutes. So this answer is a little bit weird. We have the hummingbird's heart beats 7,200 times more in 60 minutes than, than a baby's heart. Beats. Okay? So that time I didn't actually write my answer kind of in a ratio. I just wrote it out like a sentence. So we have lots of different ways how we can write this. All right, the last one deals with that idea of what is a unit price. So we have 4 identical potted plants, and they are cost 88 cents. And what's the price per plant? So unit price has to have money on top and how many on the bottom. So the problem says we have 4 identical potted plants cost $88. Now the reason why they had to tell us they were identical is because they wanted us to realize that the price would be exactly the same for each of them. So what I'm going to do is I need to get this to become a unit rate. So that means I need to divide the denominator and the numerator by 4. So what do I get? I get 4 goes into 88 22 times per 1 plant. So now I'm going to write this answer slightly differently. Each plant costs $22. Okay? All right, have fun with this. See you later.